Alright, what's up, people? Okay, it's 5:15 on the 9th. It's Wednesday. I don't feel like doing this, but I needed to do an hour at least today, so we're gonna do it. Even though I didn't feel like it, my back is not in good shape. I had to get a steroid shot today. Did the steroid shot help? I don't know. Usually they do, so let's hope that it gets me back up and going. And I'm making a big decision on a big purchase today, and I've been making it, and I'm nervous, and I'm like stressed out about it. Oh, so we'll see. Today will be the day I make my decision, probably, and yeah, I'm pretty like nervous about it. But if everything goes well, then I'll be happy in the end. So we'll see. Alright, so let's pick up where we left off yesterday. Yesterday we were doing client file. We stopped at line 572. So let's go over there. Alright, it's already open, which is cool. It saves like the state of the text editor from the last time I messed with it. And we're going to continue to implement the conversion from a 4 counter system to a 2 counter system. Get rid of this old marker where we stopped. Alright, let's read what we got to do. So we need to finish the project search for C1 apply counter. We also need to finish this section's logic in accordance with above changes. And we also need to replace the expect counter logic and adders in the same way as the apply counters. So, gotta be careful doing that. Holding control and up when you mean to just like change lines. If you are holding control while you do that, it's gonna change the position of the line that you're on, which is really, really, really dangerous if you're not paying attention to what you're doing. It could be really confusing. So be careful. Alright, let's go to the top and let's see what changes we made yesterday. So yesterday we changed it such that we didn't change that, we changed this part, right? Okay, so before we would sort the received cal tuplets based on the timestamp, but instead we now will check the current client ID, and if it's 1, we will sort based on the C1 counter, which is going to be 2, 4. Verify that. So we have 0, 1, 2, 3, 4. Alright, so that is correct. And then if the current client ID is 2, we're going to use 2, 5 to grab the C2 counter, which is the next one after C1 counter, so we know that is the correct index. Now, is it the correct logic? So receive cal tuplets, we sort it. This is going to pick 1 or 2 based on the ID, and that should be the right way to go about this, because we're always receiving everything from client 1, or rather we are client 1 in this case, the scenario. So we would always use the C1 counter. Anything that's coming to us will have incremented and used the C1 counter. Yeah, and that is the way that it works. It's not whoever's sending the data, it's whoever's receiving the data. So if the data is intended for C1 only, it's going to use to increment on the sending side the C1 counter. Yeah. And let me just check that real quick and change attribute list. pretty sure we did change some logic in here, which is where that magic happens. Yeah, we did. So now we have the C1 apply counter instead of the 1 to 1 and 1 2 2 1 2 2. We just have 1 and 2. Much more simple. We changed it so that, let's see if this part is done. The logic I was just talking about. Okay, so this is going to be the data transfer function. This, I think, is where we determine which object we're going to use, which counter we're going to increment. And yeah, so right here, if SS is SS, then we check the cal object int. And the cal object int is the, basically if we're operating on P1 game, the cal object int is going to be 1. If we're operating on player 2, the cal object int is going to be 2. If it's a shared object like the deck, it's going to be 1. And in that case, we would increment the C1 counter because we know it's going to be sent to client 1. And then if it's not a game attribute, then it's going to also be sent to client 2. And vice versa, if the cal object int is 2, we always increment 2 since we know it's always going to be sent to them. And if it's not a game adder, we will send to client 1 as well. So we increment that apply counter. And that replaced this section right here. I have to use the restroom, so let's go take care of that. I'm back. Let's, oh yeah, let me not forget to do this. To post the stream. Skip that. There he is. There he is. Okay. Let's continue. So then if it's CS, we only increment the C1 counter in case we're dealing with C1 and vice versa, 2 for 2. Alright, so let's back over here. And so far it looks like all the logic is in place. So next, what should we do? Well, we need to finish the project search for C1 apply counter. We also need to finish this section's logic. So I think what I'll do is I'll actually just continue through this section and finish. And that actually might be it. verify correct tube index after change from 4 counter to 2 counter system. If tube 4, yeah, okay, so tube 4 should be, what tube are we dealing with here? Okay, so this is tube in current client received cal tube list. Yeah, so that was what we just appended to. Up here, we append to the cal tube list. And tube 4 is indeed the C1 apply counter. And it hasn't been modified in between. Well, we can know that by highlighting it and checking. So we're just going to check to see if it has been modified. Indeed, it has not been modified, which is good. That is what we want. Okay. So this is verified, the correct index. It should be the same integers, otherwise not next data inline. Not next data point change. Next data change. Yeah, I like that a lot better than otherwise not next data. That's just really weird wording. And we'll just add a little note that says verified proper index reference, and we'll add this to the section as well, because this is going to be tube 5 for C2 apply counter, which should definitely be correct. If 1 is 4, then 2 is 5. Okay, and we're referencing tube 4 is equal to current client C1 expect counter. Append the tube to the apply list. Okay, so the apply list is empty before that. Then we increment the expect counter after we then we do the same thing for 2, C2. Okay. We have to increment this here to avoid rerunning the same logic section again immediately after. Remember, this is an immutable type, so it has to increment the actual original namespace. Otherwise, it would just create a new object assigned to that int, leaving the original unchanged, which is bad. I like how I added that in there, which is bad. Yeah, we can't like create a reference to the counter. We have to increment the actual counter. Okay, so what happens next? Alright, so that replaced this section before, which took into account the sender ID. Now it doesn't matter who it's coming from, it just matters where it's going. If it's going to C1, which means the current client is 1, then we just use the C1 expect counter. And this is where it gets checked, right? So we check it against the expect counter, and then we increment the expect counter after, making sure we have equality with it. So that is correct logic. Let's see if there's anything else we need to change. If tubes receive time was not at least 2 seconds ago. And you know, I realized I actually need to check for shared objects among objects that are not attributes, because that was just naive thinking to me, for me to think like that. We actually need to check for shared objects among non-adders. 10.9.24 realized that we actually need to check for shared objects among. Why did that look funny to me? Among, I'm like, it felt like I was missing a letter. Among non-adders, since we already checked all adders. They are just as prone to race conditions and need to be checked. Duh. Yeah, that was just silly of me to. I only did an attribute check. I mean, it's fine to do that, but you also have to check other objects. Just because they're not an attribute of a class instance or a class, it doesn't mean that they're not at risk for race condition. They're still objects. So yeah. That shouldn't take long though, because there's not many of them. I mean, there's a few, but it's not a bunch. Alright, so then we have for tube and apply list. Well, that should be good. Well, this should be good. Alright, but this should. It needs to be modified, I think. Yep. So we have timestamp dir string, because what are we iterating through here? This is iterating through the apply list, okay, and the apply list is indeed the apply list is basically the received cal tuplus. It's just the next step after it. After we filter it, so we go from received cal tuplus, or when we receive data, it goes from received change attribute list into the received cal tuplus. That gets sorted. That gets received by both client 1 and client 2. It all gets put together. It gets sorted, and then it gets passed to the apply list, and the apply list is why do we append to the apply list? Like, why don't we just use the... Okay, because then we have to... Right. Okay, I see. Yeah, the received cal tuplus contains all data, even data that doesn't need to be applied yet. The apply list, on the other hand, will only consist of data that needs to be applied. So that apply list should get populated right here based on whether or not it is next in line to be applied. Okay, so that's all good. Yeah, checks to see if it's ready to be, if it's the correct data. If it is the correct data, if it's next in line, based on whatever client we're dealing with, it gets added to that apply list rather, and then we iterate through the apply list, and then we check to see if the time, isn't this where we check timestamp? No? Where do we check? Because don't we have to check the timestamp too? Oh, we check that first. Okay, so we iterate through the received cal tuplus and we check the time. So we actually only... Is this the buffer we give? The delay? I thought it was 4 seconds. Okay, I see what's going on here. The length of the current client received cal tuplus is greater than 0. We get the earliest received time, and then if time ns minus earliest received time is greater than 2 seconds, we then create the apply list. We iterate through the received cal tuplus. Then we verify that 2 seconds for each of them. So we would, if it hasn't been at least 2 seconds, we don't apply the data. And that gets checked first before we sort it. Now, that's the question, is should we sort it first? Or is it already, no, it's already sorted, isn't it? Yeah, the sorting happens up here, right? Yeah, okay, so the sorting happens up here, so it's already sorted at this point. So we don't have to do any sorting. So this should be all good. We would check the timestamp, everything's sorted, so going in order through the received cow tuplets from beginning to end. Yeah, everything should be ordered sequentially. And then it just verifies that it's been at least 2 seconds since it was received. If so, then we would then check the expect counter against the apply counter. If it matches, then we add it to the apply list and then increment the expect counter again, so on and so forth. Okay, so after we're done with that process, we then iterate through the apply list. Let's make sure, yeah, this is the correct indentation. So for each tube in the apply list, we would then create the dir string var, tube sender ID. Okay. We do all this stuff. Then we run dir check for receive apply. Okay, yeah, right. That's correct. Alright, everything looks good there. We then remove the tuple from the received cal tuple list. We have to use remove since we can't assume a static index because not every element in the received cal tuple list gets applied in order. This would be required to use that method due to possible mismatching with apply counter versus expect counter. Okay. Right, because the apply list is not guaranteed a one-to-one match to the received caltube list. So I could put a TLDR here, which is have to use remove because received cal list isn't one-to-one exact match to the apply list. Yep, there we go. That's a little bit shorter and sweeter, I think. Then, okay, so this is where we have to make a modification, I think. So we have tube equals tube 0, 1, 2, 3, 4, 5, 6, 7. And we're reassigning the tuple to conform to its original state prior to post-receive modification. So that's removing what from it exactly? We have 0 through 7, and we ended up having how many? 5, 6, 7. Is that 0, 1, 2, 3, 4, 5, 6, 7, 8? So we're nixing the sender ID. Is that the only thing we're getting rid of? I'm confused here. Oh, no. Okay. We're reverting it to this format to just be timestamp dir string attr name data C1 apply counter and then C2 apply counter. Because I guess at this point we don't need all this other stuff. We don't need the send ID, current client receive time, sender ID. What did I just do here? Like, where was I when I did this? Okay, so I was after this. Okay, here we go. So we're looking at two. So we want to reassign it to conform to its original state prior to post-receive modification. And that would be just having timestamp, dir string, attr name, data, C1 apply counter, and C2. So it would be 0, 1, 2, 3, 4, 5, but not 6 and 7. Yeah, so this can go away. And we stop at 2, 5. So yeah, we have timestamp, dir string, attr name, data, and then the C1 and C2. So this needs to be changed to C1 apply counter right here. Same thing. Change that to 2. Alright. There we go. So this line, we can actually make a little comment for this. Reset to virtual state. This is gonna not have the last 3 entries. So it just has 0, 1, 2, 3, so it has 6, 1, 2, 3, 4, 5, 6. Yep, that's right. Okay. Then we check current client ID equal to 1. Alright. Now this is not going to matter. Well, that I'm not sure about, honestly. The sender ID being equal to 1. So does the sender ID matter anymore? That's the question. It doesn't for the other section that we worked on, but that doesn't mean it's not important here. Because I think we still need to have the 4 storage dictionaries. So this will take some thought. I really didn't want to have to do this, but yeah, I think I'll have to review this, the necessity of this. Damn it. So we have to ask ourselves, since we're going from 4 counters to 2, does that mean we only need 2 storage dictionaries instead of 4? Well, I think we still need that because the storage dictionary is to keep track of everything that we've received, right? So like if we receive something from client 1 to client 1, we would store it. And in the case that data from C1 to C1 was lost somehow, we would be able to verify that by checking the C1 to C1 storage dictionary. Now the question is, could we accomplish the same thing with just having a C1 received data storage dict and just disregard the sender ID like we do with the apply counter and the expect counter? I mean, I would like to think we actually could accomplish the same thing, because all that we're doing is checking yeah, all that we're doing is checking to see if we've received a particular data point change. At least I'm pretty sure that's, that's all that this does. It's just for basically verifying that C1 received certain data. But as long as that data has a unique identifier that the sending client can send us so that we know what we're looking for, it'll send us that unique identifier. We could look in client 1's C1 received data storage dict. Yeah. And we're just looking for that that piece of data based on that unique identifier, and that unique identifier would be well, it would be the apply counter, right? Because that's the apply counter is always unique for every data point change relative to each client. Now, relative to each other, C1 and C2, they're not unique. Like, they both start off at 1 and go up, so you have 1 through 20 for C1, but each one of those is going to be a different data point change with a unique, that unique number, the counter, as the identifier. 1, 2, 3, 4, 5. It's not going to skip or whatever. And as long as you're checking the right client's received data storage dict, you would never run into any issues with that. Yeah, so I want to say that logic works without having the 4 of them. But this is something I don't want to just lightly change, because I like to think that I'm smart sometimes and that I make good decisions, but I also know that sometimes I'm not so smart and I make bad decisions. Maybe the implementation of the 4 storage dicts was overkill. Maybe we don't need 4 of them. The same thing can be accomplished with 2 of them. We could use 2. But if it's more efficient to use 4 of them and it doesn't cause bugs, then I would rather use 4 of them. because for one, it's already implemented, and two, if it increases performance, I'm not going to opt for more simple code if it's not good for performance. So let's see if it's it is reasonable to keep the 4 storage sticks. Okay, so we have our while true. This is in client. This is at the beginning of the main while loop. The first thing we do, this is the filter sent received dict section. So this is where we're filtering out data that we know that has been sent and data that has been received. Basically, like, we have a storage place for all of our received data and all of our sent data, and we keep it populated as a backup and a log. It's a backup for relative to our side, the sending dict, just in case if we go to send something and it doesn't actually get sent, we have it in the sent storage dict so that we could resend it again. And we have the receive dictionary so that we keep track of everything we've received, so that we can then let the other client know if it's like, hey, did we send this to you? The client's like, hey dude, I'm gonna go check my storage dictionary and look, and hey, guess what, you did send it to me. And then that client can then say, okay, you got it, it's applied. We can then remove it from our sent data storage dictionary. We don't need to save it anymore. We already know you got it. We don't need to hold on to it anymore. It made it to its destination, so we can destroy the copy of it because you have the original, whatever, you see. So that's the purpose of these 2 dictionaries. Now this logic here will iterate through the received storage dict and the sent data storage dict, but it only will iterate through 1-to-1 received, 2-to-1 received, and the 1-to-1 sent. And that is a correct assessment because we do receive from client 1 and client 2. So I honestly think we could keep the 4, and it would actually, like, not only be fine, but probably be more efficient. I might be wrong here though, because it is a dictionary. So if we're accessing it by a unique identifier, like efficiency, quote unquote efficiency, like, is gonna remain the same if we're always accessing the dictionary based on the key. You know, if we're not having to, like, search through it because we don't know which client it came from, that should be irrelevant. The sender ID should be irrelevant as long as yeah, that's the whole point of changing from a 4 to a 2, is it doesn't matter who sent the data. It only matters where the data ended up. So if it came from client 1 or if it came from client 2, we can still use that unique identifier, which is the apply counter, to find that stored data based on that counter. So basically the counter would be the key and the actual data would be the value. Yeah, that sounds good to me. Like, so in that case, there wouldn't be an increase in efficiency by using 4 instead of 2 counters, and it would be simpler to use 2. So let me just look at the rest of this section. So we iterate through the dictionaries, we check the length of the dictionary, we then iterate through a copy of the dictionary, we grab the core data using the key, and the key is going to be, well, the key, I don't know what that consists of at this point. I think we use the send ID. I think that's what we use, the send ID. But like, I'm pretty sure now that the apply counter in essence does exactly the same thing as the send ID, meaning now I think the send ID is redundant. I don't think we need to have both the send ID and the apply counter. They now have the same function. Yeah, because that is a unique identifier associated with every send. And I'm just like, well, would that work both ways? If the client is sending to the server, it is gonna send, if it's client 1, it's gonna increment the C1 counter. It's gonna send that, let's say, as that unique identifier. The server is gonna receive it, and then the server would then store in its received dictionary the C1, proposing that we switch to a 2 dict system instead of the 4. We would store all received data, which would always come from its associated client, because server side only receives from the client side, obviously. So it could never receive from client 2 if we're working with client 1 server side, which means having the C1 apply counter be populated would be perfectly fine. Get this shit out of here. Alright. Yeah, if for dictionary, so yeah, from sending from the client side to the server side, it would increment 1. It would receive 1 in the C1 storage dict. It would have that unique identifier. Yeah, so like, I don't think there's a reason to have a send ID, like a separate send ID. That counter, in essence, like, becomes the send ID. So it's just much more efficient. You're killing 2 birds with 1 stone. Yeah, it's like way more simple. Unless I'm missing something. I gotta use the restroom again. Had to answer my pants, you know? When you gotta go, you gotta go. Alright, so what's going on here? Okay, yeah, so we were working our way through the C1 to C1 storage dictionary logic to see if we could convert to a two dict system from a 4 dict system. And we also noted that it seems like we would also be able to nix the send ID, as this would basically take the place of it. Okay, so we would iterate through that dictionary, we get a copy, we grab the core data, we check the type of the core data to see if it's an int or a string, which means it would be a receive verification or a resend request. Okay, that's, what about if it's a, well, if it's a list type, we don't store that. Well, no, that gets removed. That gets removed in a different section. So that does get removed, but it gets removed in a different section. And we could move that to be done here. It is nice to be organized, but if there might be a reason why we need it to happen at that point in time. I think it probably saves us a little bit of computation. I actually don't know if that's true. We very well may move the sorting, the removal of the change attribute list to this location as well. I'll have to figure that out. I'll put right here, below line 4, should we also include list type objects here, received changed attribute lists. Since this is organizationally the correct spot, right? Or is there a good reason to leave it where it is? Immediately filtered out after reception of associated data. So like we actually just, as soon as we receive it, we check to see if that yeah, as soon as we receive it, we check to see wait a second, hold up, am I confused here? So when we receive the change attribute list, we store it in the received data storage dictionary, correct? Okay. And this is where we filter it out. Okay, I know. Okay, so we remove that received change attribute list from the received dictionary whenever when do we remove that? that's removed after the data is applied. So like we receive the change attribute list, we apply all the data, and then I actually have to ask, where is this done? Because I had it confused. I had it the other way around. That would be for um, when we send data and then subsequently receive back from the receiving client a receive verification. At that point, we would then immediately remove that associated sent data from the sent storage dict. The received data, as far as the change attribute will fall under if the core data is equal to list, not here. I just need to go look through the rest of these instances to see, because that'll tell me the answer to my question. Okay, hold up. I see what we're doing. We're creating a reference to it, and then we're okay, so now we have received data storage dict. Let's see, what do we do with it after this? So let's highlight it and let's see. Okay, so we receive all data into the received data storage dict at the particular send ID. Okay, so that it doesn't matter what kind of data it is, we don't check, we store it all. And then if the type of core data is equal to the list, see where else is it used? Okay. So this is, what section is this right here I'm looking at? This is the application section. We delete from the received storage dict, since all data from it. Okay, so this is where we remove it, right here. This is what I was looking for. So this is done after application. And it's convenient to do it right here because we're already dealing with the associated, we're already dealing with the change attribute list. So we're iterating through the apply list. This is where we apply the data based on dir check. We then remove it from the received caltube list. Okay, and then we figure out the proper received storage dict. We then grab from that dictionary the associated received change attribute list. Okay, this is true. Then we would remove the tuple that we just applied from that change attribute list. Okay, and then we check to see if the length of that change attribute list is 0, which means we've applied all the data from that just call it cow from that cow. We then delete that received data storage ticked entry, so it no longer exists in that received ticked. Okay, yeah, that's fine to leave there. Um, that actually is a better spot for it, I think, because otherwise we would well, you know, it really doesn't matter. Like, I don't think it really matters much. Whether we have it here in the filter section, if we had it here, we would iterate through the dictionary, and we would iterate through each key. Okay. And we would check to see how long it's been since we received that key. But we don't want to delete any change attribute list stuff based on a timestamp. So that's why we don't have that here. And that's why we don't want it to be here. If it was here, then that would make it such that we would delete non-verified. We would delete data that may not actually have been applied all the way. So yeah, this actually wouldn't be a good spot for that data. Good deal. Alright, so we figured that out. I will put this as a note right here, just in case I wonder in the future. Say, we don't handle list type here. Received, changed, attribute lists. Because we don't want to ever remove them based on time, and because we already removed them in the application section. So that will help me remember that that's the case. And I could make this into a function, right? Yeah, I totally see how I could make this into a function. Yeah, I could improve this. So instead of having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Instead of having whatever, 18 lines, 446 to 464. That's 18, right? Yeah. So instead of having 18 lines, we would have 9, 10 lines. That's almost a 50% reduction. Let me just make sure that I could do that. The only thing we would have to have is we would have to have a list, or a dictionary rather. No, we could just have a simple variable actually. No, well, I'm dumb. We just make a tuple. That's all it needs to be. Alright, so yeah, we can totally do this. This is all the same. let me check. So line for line, current, that's already established. Check client ID. Alright. Then we iterate through the dictionary. Then we check to see the length of the dictionary. Then we run this copy. Okay. Then we have the core data, exactly the same. Below line, same. Checks the type, exactly the same. If the current time minus dictionary at key is greater than or equal to 28 gazillion, we then delete the dictionary key. Yeah, so we could totally turn this into a function. And remember, we don't have to pass items in as args unless we modify them in the function. So the only thing that would need to be passed in as an argument would be anything that gets reassigned. We don't actually reassign that core data, that gets assigned, it's created there. So the only thing that gets modified here is the dictionary. But that would already, like, that's just the namespace for the object we're iterating over. So we wouldn't actually have to pass in any argument, I don't think, and we wouldn't have to return any value from it. If I understand this correctly. Yeah, so we could get the current time, which we need for what? Okay, so we need that inside of the function that we're about to create, which means we would need to have that line executed inside of the function. Yeah, as long as we execute the line inside of the function, we are good to go, right? Is that true? Yeah. We couldn't have it outside. No, well, we actually could. We could have it outside. But there's no reason to have it outside. So that would just be silly. So we'll do it. We're going to say def, definitely. And what are we going to call this function? We'll call it def filter dict func. I don't know. And then we would indent this to the inside of the function. We would then add in a line right here which says say dict tup, because it's a tuple of dictionaries, and then we'll create a tuple which would consist of, in this case, these three dictionaries: the C1 to 1 received, 2 to 1 received, and the 1 to 1 sent. Alright, but elif, or else, which would be the same as saying elif the current client ID is equal to 2, we would then get rid of these double stamps of approval since we're modifying it. We would then have a dict tube which consisted of these three: the 1 to 2, 2 to 2, and 2 to 2 sent. So right here we have, if your ID is 1, we have 1 to 1, 2 to 1, 1 to 1. And then if it's 2, we have 1 to 2, 2 to 2, and 2 to 2 sent. Alright, now this would get unindented, so we have current time. We check the current ID, assign the dict2 else, which means current client ID is 2. Our dict2 is different, and then we would say for dictionary in, instead of this long thing, we would just say dict2. So it's now going to iterate through each dictionary in the dict2. So that's just a variable now. We then check the length of the dictionary. Everything could remain the same, like all this stuff should be able to remain the same. Yeah. So we can then get rid of this entire other section. And look at that. Look how much neater that is. Then we would call the function. Okay, I see. Well, I was gonna say we would need to pass in the current client ID, but I don't even think we need to do that because it since we're not modifying it, we should be able to reference it. Yeah, I think so. Unless it considers the client object as itself being modified, since we do delete from the dictionary, which is a current client attribute, then if that was the case, we would have to pass in current client as an argument. I'm not sure, honestly, if it would make me pass the current client object in as a dictionary. I'm gonna trust ChatGPT. I'm gonna put my faith in the AI real quick. We're gonna first call this filter dict func, and we're gonna leave it as is. Okay. But here's what we're gonna do before we ask AI. We're gonna rewind time. We're going all the way back in time to before we made the function. Okay. Then we're gonna copy this whole section. Alright, so now it's copied, and now we're gonna redo all the changes. So now we're going forward in time, and that was fast. Alright, now we're gonna separate this section. We're gonna paste it in, and I think we could also make this where we don't redefine the function every time the while loop is run, meaning we could assign this outside of the while loop. Yeah, I'm pretty sure we're good on this. We could hold up. Alright, yeah, let's comment this out. And then we're gonna put a caution comment. So below section 10. Disabled the term being replaced by above section. Being replaced by above section, and then what? I want some chocolate, dude. I'm craving some chocolate. Anyway, Being replaced by above section, leaving this percent sure. Change is valid. Yeah. So now we're gonna copy this div here, paste it in 2, 3, 4, 5, 6. There you go. And now we're gonna have a div for this. Boom. All right. So the question is, will this code work? We went from 462 to 481, which was 19 lines. And now we have 445 to 460, which is 15 lines. So we saved 4 lines. Was it worth it? I don't know. Maybe it was worth it. We saved 4 lines. In the 4 is what percent of 19? It's like 20%. Yeah, basically 20%. So that's a 20% code reduction. That's actually pretty good. If I could reduce 20% of my entire code base, that would be really cool. So we just need to ask Chibbity Jibbity if we will need to pass in the arg here. Let's ask Gemini first. We'll say end all the way down. Say, will the above code work without passing in current client as an arg, since the dictionary variable is technically the current client's dot receive current client's received dict. Or would you say the current client's dict? Meaning that since we are technically modifying the current client objects dict, that modification would require code you enter will likely work without its passing. Wait, why does it not? Okay, there we go. It says, whoa, hide the draft. Right. The code you provided will likely work without explicitly passing current client as an arg to the filter dict function. Here's why. Global variables. The code seems to be relying on global variables like current time, current client. These variables are likely defined outside of the function and accessed within its scope. Modifying in place. The code iterates through a tuple dict containing references to dictionaries within current client. By modifying the dictionaries with the loop, it effectively changes the original dictionaries associated with current client. However, there are some potential issues. Using global variables can make code harder to understand and maintain. It generally is better to pass the necessary data as arguments to the function. Side effects. This function modifies external datas, dictionaries, and current client without explicitly stating it. This can lead to unexpected behavior with functions called in unexpected ways. Okay, instead of relying on the global variables, So I was actually concerned about a completely different thing that wouldn't have occurred here. I was concerned about I was concerned about actually referencing an object I guess modification is okay. It's reassignment. If I were to reassign something, right, so deleting from an object is just modifying it. It's not the same as reassignment. If I were to reassign the dictionary, that would be a problem. But if I were to reassign the dict, that would cause an error, right? Yes, reassigning a dictionary within a function would likely cause an error. Tuple mutability. The dict tuple is immutable. This means you cannot change its contents after it's created. No, not like that. Well, he's actually right, but I meant, okay, ignoring the type error you mentioned, wouldn't it be disallowed since I would be reassigning a namespace that wasn't passed in as an arg, meaning that it wouldn't allow me to it would cause an unbound local error. It knows what I mean. Yes, you're absolutely right. If you were to attempt to reassign a dictionary within the tuple, you would indeed encounter an unbound local error. Tuple immutability. Tuples are immutable in Python. This means you cannot modify their elements. No, not the tuple, man. If you try to create a new dictionary within the function and assign it to the same variable name as the dictionary in dictube, you'd be creating a new local variable. This would not modify the original dictionary associated with the current client. You'd be creating a new local variable. Right, which means that if I used that namespace, current client C1 to C2 receive data storage dict equals XYZ, that would result, well, actually, no, that wouldn't result in an error. No, I'm tripping. It wouldn't cause an error. I was confused. It's okay. I see now. So yeah, this code should be good. Now back to the topic at hand that we were messing with, that we were on before I got distracted and made that little function improvement. Oh, see, the only thing is current time run, is current time going to be rerun every time the function is called? I had problems with that before. Would time.time ns be rerun every time I call that function? Or would it always refer to the time at which it was assigned in the function's definition? Totally just had a bug on my face. Time is a function that returns the current time. This means that every time you call it, it will return a new value. When you call it, return value. Okay. is a function that returns the current time in nanoseconds. This means that every time you call it, it will return a new value representing the current time. Okay. Here's a breakdown of how it works. When you call time_ns, the Python interpreter executes the function and calculates the current time in nanoseconds. Okay. Executes the function and return that. The function then returns its calculated value as a result of the call. Subsequent calls. If you call time_ns again, it will calculate and return the current time at that moment. Therefore, you cannot rely on time_ns to store a fixed timestamp within a function's definition. If you need to store a timestamp for later use, you should assign the result to a variable within. So a current time will hold the timestamp from the initial call to time_ns, and you can use it throughout the function's execution. To store a fixed timestamp within a function definition. Okay, I'm still a little bit confused about that. We can test this though. This is, I would rather, if I can test it easily, I'd rather test it. Testing is more reliable than asking chippity jibbity. Or Jiminy. Chippity jibbity and Jiminy. We would, in this case, say what? We need to create a function called f. Then we also have to import time. And then we're gonna say time.time_ns current time, or we'll just say ct for current time. And then we'll print ct. It's probably not going to work because it's not going to know what that is. Right. But if we put this inside of that function, and now let's call f, and then we'll do time.sleep for 1 second, and then we'll call f again. So in this case, we know that it's getting called 1 second apart, and 17285170076, and then this one is 172851707. So that it goes from 6 to 7. Okay, so this code does work as you would expect. I was concerned that t would always equal, you know what I mean? Like it would get assigned when it was when this function was defined, and then it would always refer to that same. I'm pretty sure I experienced that before, or something like that. Maybe I imagined it. I don't know. And let's run it a third time just to be absolutely sure. So all three of these are going to have different values. 172851713, and then we have 32, 33, and then 34. So that would be our second marker, and they do indeed happen 1 second apart. At least 1 second apart, actually. This was 2-9, and then 3-9, 9, yeah, very close. All right, cool. So we know it will work, and I'll just leave this one because I'm always wondering about this one. I have trouble remembering this. We'll call this the time in function. Reminder that time in s called within a function assigned to a variable will always rerun and give you value. It won't assign it at and same. Okay. Yep. And R26. I'm gonna use it again. Just a second. There it is. There it is. Alright. Back at it. Let's finish. I'm gonna just do the 2 hours, which we're almost there. 30 more minutes. Let's go ahead and smash this 30 minutes. And alright. So we'll close this. Back over here. Alright, so this should work. And we were going through the C1 to C1 previously, and I'm pretty sure, based on everything that I have thought about and considered, that we would be safe in making the change over to a 2 counter system. Because instead of using the send ID as a key, we would instead use the okay, hold up, wait a second. No, we couldn't use the yeah, so the send ID, we could use that change attribute list we could use that change attribute list first data point change apply counter as the send ID, but that would be kind of tacky. I think we will leave the send ID because the send ID starts off at 1 and gets incremented every time we send, so it just goes from 1, 2, 3. It's a lot easier to like read if it's jumping around from like 6 to 12 to 14 to 20. It all depend. That would all depend on how many data point changes were inside of each received change attribute list. And since that varies, there would be no consistency. Yeah, so moving on to yeah, so we would keep the send ID. Okay, I just realized though, if we were to make that change to the 2-stick system instead of the 4, that would be problematic because the send ID is per client. So let's say sending side, so sending side, let's say we're operating from client 1 thread. Our send ID would be based on client 1-to-1 send ID. So we would have to change from having a C1, because we have 4 send IDs, right? We only have 2. Do we not have more? Okay, so we do have 4 of them. We would have to change from 4 send IDs down to 2. And that just means okay, now that would actually be problematic. That would turn the send IDs into a shared object, which they would compete thread 1 and thread 2 server side would compete for the C1 and C2 send IDs. And that would hinder performance because we would have certain times where we would be blocking when one thread, client one thread, is trying to access the C1 send ID while client 2 is trying to access the same object, because it's going to be sending to, well, hold up, wait a second. That's not, hold on. I'm not thinking correctly. I don't think I'm thinking correctly. If we have, no. I'm looking. All right. Yeah. If we switched to two send IDs instead of 4, whenever we sent to client 1, we would use the C1. Is that right? And well, yeah, in that case, C2 sends to C1 and C1 sends to C1. So they would compete for that send ID. Now, if we use the send ID for sent from, if we sent from C1, we would use the C1 send ID, or we would send from C2, we would use the C2 ID. That would solve the issue of the objects being shared server side. But would that work? Like, would the rest of the logic check out? Let's think about this for a second without using paint. Let's see if I can just word this out. Alright, so the send ID for C1 from client side, we would use C1 send ID. Anything sent from server side client 2, we would use the client 2 send ID. So if C1 sent to C1, it would start at, the ID would start at 1, and then that would be a unique identifier, and that's really all that matters as far as receiving side is that send ID going to be a unique identifier. And then if C1 sent to client 2, it would use C1 counter, but in that case the counter would, the send ID, not the counter, the send ID would be 2 instead of 1. And client 2 would receive it, and the send ID is not the expect counter, so it doesn't get compared against, right? Like, the send ID doesn't matter, the value of it doesn't matter as long as we don't have 2 of the same being sent. The send ID relative to the receiving party always has to be different. It has to be unique. Okay? Okay, so what about this section? What is this doing? For key and sent data storage, dict copy. If type of, so this is for each key in the sent data storage. If we sent a resend request, I'm just trying to make sure that this doesn't, like, the send ID doesn't have to be anything in particular. It's just checking to see if this send ID is equal to a previously requested send ID. But what would determine if that was a requested send ID? Well, we would request it if we were told that we were going to be receiving something, but we didn't. Just need to send any message, any resend request IDs. I can't remember. How does this work with resend requests? If the word is equal to enter, this checks what it is to determine if receive verification or if it's a resend request. Okay. That's okay. So data will be in 1 of 3. If we have a resend request, yeah, but how do we know to ask for a resend request? That's my question. Removes fulfilled resend requests. See if any send ID matches any resend requests. Okay, yeah, but this is not, that doesn't answer my question. This. In case of receiving receive verification or resend request. No. I want to see. So we actually I don't see anything here in client at all that asks for a resend request. But we totally would need that. Like, how do we receive resend requests? What determines that? Check score data type determined. Okay. So this is all for receiving, but what about sending? So what is this? Okay, that's for receiving. But what about sending? This is the receive section. Still not what I'm looking for. Okay. I don't see anything here. fulfilled resend request. Okay. Particular element is a resend request. Yeah, but how do we receive? How do we how do we send out a resend request? We would say, hey, have you sent us this data yet? But like, how would we know what data we're looking for? My bigger question is, if we're relying on like an incremented version of the send ID, then that means we wouldn't be able to use an arbitrary value for the send ID, which would be the case if we it would be the case if we change from a 4 send ID to a 2 send ID system, because sometimes we might be sending to client 1, sometimes we're sending to client 2, and if the send ID is determined is based on which client we're sending from, the receiving client will might receive send ID 1 and then 2, and then it might not receive 3, it wouldn't receive 4, but then it would receive 5. So there's no way for the receiving side to know which one would be next. See what I'm saying? It would not be able to say, okay, we last received 2, so that means we were looking for 3. We haven't received 3 yet. Would you go ahead and resend us 3? But I don't know like how. I don't think this is coded. This is not even, that's not in there. Added in logic for removing resend requests. Okay, let's see. Some good things to do. It might be in here. Currently, if this logic for detecting lost data, I don't believe we currently have a system in place to detect data that was sent over the network was lost and the client never received it. Currently, if this happened, the receiving client would simply not apply data. There'd be no way if it was lost to make a resend request. Yeah, that's what I'm asking here. See? Need to add logic for this eventually. Quite sure this would be rare, but it could happen. For stored change attribute list, stored for at least X seconds would be checked for receive verification. If receive verification hasn't been sent by this time, check to see if it was received. If it had been received, but no receive verification had been sent back. For stored change attribute list, stored for at least X seconds would be checked for receive verification. Okay. So if someone sent data, the data gets lost. Okay, right. So we would have the sending side go ahead and say, okay, we never received a receive verification for the data that we sent. Did you receive it? And then they're going to say, and when we say it, that sending side would have access to that send ID. So it's not based off an incrementing of the send ID. It's based off of a reference to the send ID from the sending side. We'll resend it and be like, hey, we never, you never sent us a receive verification. Did you receive this data? And then if the receiving side receives that and then goes, oh, yeah, we actually did receive that data, then we would need to disregard the resend request, or we would answer the resend request with a receive verification. to say, hey, yeah, we did receive that. That would have meant our receive verification got lost. Okay? But then if we hadn't received that data on the receiving side, the send ID, we would say, no, we haven't received that, and then we would request for them to resend it. And we would have access to that send ID because they would have just sent us a request saying, hey, you never but I was just thinking there's actually a way to do this wherein we did use an incremented version of the send ID such that we would such that instead of the sending side asking the receiving side if it had received a certain change attribute list, the receiving side would instead keep receiving data, and then after a certain amount of time, if it hasn't received the next send ID in line, so if they had received 1 and 2 and then 3 but then never received 4 but then received 5 and 6 and 7, at a certain point it would say, hey, you sent us 1, 2 and 3 and then 5, 6 and 7, but we can't apply 5, 6 and 7 because we're still waiting on 4, and we want to check and ask you, did you send us 4? And then the sending side would go, hey, yeah, we actually did send you 4. It must have got lost over the network, so we'll resend it to you again. Now it's just a question of which system is simpler, which one is more efficient, and which one makes more sense. And I think as far as, well, the main thing is which one makes more sense. The one that makes more sense to me, I think, would actually be the 4 send ID system, because that's the one that would allow us to use the latter option where we're checking the send ID incrementally, and that just seems more simple. Like the other system wherein the sending side waits to receive a receive verification and then never receives that receive verification, and then says, hey, we sent this to you, do you need, but we never received a resend request, do you actually still need that data? Did you already receive it? That's just as simple, really. They're both equal up until that point. Just thought about it then. So in that case, sending side say, hey, I sent you this data a while ago. We'd pick a certain time to say, hey, it's been a minute, you never sent me a resend request. I mean, a receive verification for this data I sent you. Did you receive it? So then we would send out a, what would that be identified though as? It's not a resend. We would basically just be sending data to them that would be asking if they received a certain piece of data. And that is a little bit different. We don't actually have classification in place that would be type of send. Like a resend inquiry, we could call it, like a resend inquiry. And the receiving side, okay, we got your resend inquiry, and then they're gonna check and say, did we actually receive this? Because the only time they would remove that from the received data would be if they had already applied all of it. If they had already applied all of it, well, then it actually wouldn't exist in their storage dict anymore. But I think we do have another storage dict that just keeps track of everything that had been received in toto, that just stores the send ID. So then we would say, hey, did you receive this send ID? We would send out the resend inquiry. And then the receiving side would go, okay, we got your resend inquiry. You're asking if we received, would you say 3? Did we receive send ID 3? And then it's going to check that master list of received IDs. And we're going to go, yeah, we actually did receive 3. So then we would have to send back to them a receive verification, which in that case the receive verification would have been lost, and then the other system would be completely different. It would rely on the receiving to check for IDs, and it would say, hey, we got 1 and 2 and 3, we didn't get 5, 6, and 7. It's been 1 minute. Did you send this to us? But I'm like, honestly, we might have to have both of those systems. We might have to have both of them, because one of them is for instances wherein receive verifications are lost. So if a receive verification gets lost over the network, then that means whoever sent the data is never gonna know if you actually, like, did you receive it? We don't know. You never sent a resend request. So we might just keep sending data while the other side is actually waiting to receive that data. It's not going to apply any more data until it gets the one that it never got. But if there isn't logic in place to request data that it never got, like, how would it know what data it is that it never got? It would have to know. It would have to say, hey, we got 1, 2, and 3, but we never got 5, 6, and 7. I mean, when we got 5, 6, 7, but we never got 4. So that would cover lost. Did I get that backwards there? We have, I think I might have had that switched up. For the cases where data was sent but never received or verified as received, where just the receive verification was lost, that would, and let me write this down. I'm just gonna write this down right here. Let's go to things to do. Where are we at here? Where did that file go? It was here and then it just disappeared. Things to do, there it is. Alright, let's put this first. And Go all the way up to the top. Because it's kind of hard to keep track of this. We'll say, what is this related to? Receive verification logic. All right. We have number 1 for whenever receive verification is lost over network, and then we have scenario number 2 whenever change attribute list is lost over network. Now, ideally, we would have one solution. Ideally, we have one solution which solves both problems, but we might have to have 2 different solutions. We'll say, so we'll do this like this. For whenever receive verification is lost over network, this depends, and we have to put, I'll add this as a note, this solution depends on whether we have a 4x send ID system or a 2x system. If we have a 4x system, we can use the 4x receive dict to determine number 1 no, that would be for number 2 to determine number 2. We could check the receive for the next in line 1, 2, 3, 4 missing, 5, 6, 7. So we could check for the next in line 1, 2, 3, 4, which is missing, 5, 6, 7. Send ID. I know this is really scatterbrained, but in this case, no, 4 would be missing. Send ID 4 would be missing. Therefore, after 1 minute, we would 1 minute of not receiving the next in line would request for that data to see if it has already been sent. And this is starting to get into the nether realm of just like really complicated but kind of rare scenarios, but like they technically could happen, so you have to cover them. It's just terrible, honestly. Ugh. Just yuck. Just thinking about that stuff makes me depressed. Anyway, we can check for the next in line, but if we had the 2x send ID system, we wouldn't be able to do this, since we would not know which send ID was quote unquote next. since C1 thread could send C1 thread and C2 thread use the same send ID. Let's say C1T send ID equals 1, then or C1 thread so we have C1 said, and this would be sent to C1, but then we have another one where C1 send ID is 2, but this is sent to C2. Therefore, from CS side, wouldn't know which send ID would be next. It could be 2, 3, 5, 100, etc. But with 4x, we always go from 1 to 2 to 3 to 4 from all endpoints. Okay, so this is for determining number 2. So we'll put that under number 2. And I'm actually going to stop here. I will have to add this in. Put it right here. So this is stopped here. This is 10, 24. Put this, which says when considering the changes to this system, not to this system, to the 4x send ID system, we have to figure out how it would interact or affect the receive verification systems. Let's put C concerns left in things to do at line number 16 through 29. Right. Now, in devlog, we're gonna stop here. 7, 24, 26. So it'll take me a minute to commit these changes. 726. 5:15 to 7:26. That's 2 hours and 11 minutes. So what do you say? 2.25 hours. So 24. I'm gonna commit the changes, and we stopped at line number 596 in client 5. Okay. This is going to be 725 to 7 or 727 rather. No, I'm an idiot. 725 to 726. Silly goose. Alright. Now we'll go down to terminal. We're going to make sure we're in the root of the project directory, which we are. Then we'll do git branch to make sure we're on the right branch. We are. Git add to add everything. It added everything. We'll do git commit -m, paste that in. Boom. We made our commit. 4 files changed, 78 insertions, 24 deletions. We'll do git push Canasta secondary, and it's going to push to the remote repo. Alright, now we're going to exit out of this. We'll go over here to programming, projects, Canasta, copy the current, go to the backup, delete the old one, and then paste it in. Alright, go into that, go to text, go to debug, and look at the end. It is today's date, so now we can be sure it's the correct directory. Now change the date and exit out of that, and we're done, and I'll see you maybe